In pseudo style, we know that we replace the pull-up network by only one PMOS transistor whose input is always grounded, and the pull-down remains same like static, which is nothing but A parallel to B, and this is nothing but my ground, and the output will be taken in between the pull-up and the pull-down network. So very straightforward, pull down exactly the same, pull up replace it with a pseudo NMOS, or in simple words a PMOS, which its input grounded or it's always on. Now you can put the values from the truth table, different values of A and B, and you will see that it satisfies the conditions and you get a proper output. Let's go ahead and do this in dynamic style. So in dynamic style, we know that pull down network of A and B in parallel will remain the same. Along with that, we'll have a header transistor and a footer transistor. Header is going to be above, so it's going to be a PMOS, and footer is going to be below, so it's going to be an NMOS, and both of these inputs would be shorted, and we call this input as input phi. PMOS has another terminal connected to VDD, NMOS to ground, and you have already seen this, that the connection needs to be made between the pull up and the pull down network, and this footer is always going to be connected in series to the pull down network of the static circuit, and that too below the entire pull down network, not above it. Remember, series can be either ways, but we'll have to connect it down because we want to ensure that there is no direct path between VDD and ground at any point of time. We have already discussed this in previous clips. So this is nothing but my static circuit. This is nothing but my dynamic circuit implemented from static style by adding a header transistor and a footer transistor. Let's quickly implement this using C-square MOS logic or clock CMOS logic. Here we saw that we need to draw the same circuit like it was for static CMOS. So here is my pull up, here is my pull down, this is input A, B, VDD, this is ground. This is exactly the same, but we only saw that the only change would be there will be an additional PMOS connected in series closer to the output to the pull-up network, and there will be an additional NMOS connected in series closer to the output to the pull-down network. Let's quickly draw this. So a PMOS connected in series closer to the output, and NMOS connected in series closer to the output means this is the point where my output will be taken, and this is going to be phi, and this is going to be phi bar. So this is nothing but my 2-input NOR gate in C-square MOS style. So here we have seen that after implementing a 2-input NOR gate in static style, from there on we implemented in pseudo NMOS, from there on we implemented in dynamic style and C-square MOS logic style. In further clips, we have also seen or will be seeing how to implement this NOR gate using pass transistors logic and transmission gate logic. Hope you have followed. Stay tuned. Thank you very much.